Greetings from India. This is Nirbhay Chauhan from Eklavya Self-Learning Tutorials. Well, today in this tutorial, we'll be discussing how you can utilize the Spreadsheet workbench in conjunction with your BIM workbench to make parametric models, or in brief, we can say parametric BIM overall. So we'll utilize the functionalities of the Spreadsheet workbench, which comes along with your FreeCAD. So we'll see the functionalities overall and how beneficial it is. Before moving to a practical example where we'll do an exercise, we'll see this model where we can see the functionalities, how the parametricities can be obtained and live synced. You can see you need not to visit your model properties, your sketches again and again for modifying your dimensions. Simply, you can control via spreadsheet, but there are certain formulations that you need to do. So we'll discuss that. And the bonus part is at the end of this tutorial, you'll get the link to this particular file along with the file that we'll be doing today. So here you can see I have a framed structure, or you can say a multi-story building here with certain columns, certain beams and slabs. I have made it transparent for your convenience. So now if you see in the spreadsheet right side, we'll try to change the parameters here. So you can see the column size first. So I'll show you briefly here. The column size by default is 2 feet by 2 feet. Let us make it 3 feet, and I click enter by 4 feet. And you can see the changes are synced automatically, very lively in your model. So you see you're done with the column sizes. Now let's move forward with the beam size. Make sure you do right dimensions while entering here. So the width here is for the beam, this greens one. So we can enter it's something like 2 feet, and you can see it changes, and the depth you can make as 3.5 feet, and you can see the depth of the beam has changed throughout the model. So you see you can take use of single model multiple times with the help of this spreadsheet workbench and assigning certain parameters to your model. Moving forward to the slab size, you can see here the slab size right now we are given as 6 inches. Let's make it as a 1 feet. So you see it has changed throughout. Now the offset, basically what's offset is, basically if you just see your top plan, these outer boundaries with your main structure within. So this is marked as 3 feet from all sides. Let's make it 1 feet, and you can see it has shrinked. So it's quite less. We can move with 4 feet, say, and you can see the offset has been synced with your model. Moving forward, we have the building layout. So this is interesting part as is conveys with the array. So here, the first thing is center to center distance, the X distance between your columns, which is 15 feet. Let's make it around 20 feet. And you can see they have been elongated. Then we have center to center distance, the Y distance between columns, which is this one. This is 12 feet right now. Let's make it 15 feet. Oh, sorry. Let's make it 15 feet. And you see, it has been changed in the Y direction as well. Then forward, you have the spans in X directions. Right now, these are 2, which is 1 and 2. Similarly, for Y direction, 1 and 2. You can make it like 1. And you see, you have only one section now. For Y as well, you can make it as 1. And you have a very single frame structure. Okay, similarly, when you see in the next part, which is the story height is 11 feet. Let's make it 15 feet, and you see they have been changed. And number of stories are 4. We can make it 10. See, they are replicated, or we can make it 1, and then you obtain a simple structure. So how these things are done, how we are linking the spreadsheet with the your BIM model. You can obviously see this model in your meantime, but we'll discuss how you can assign these parameters with a spreadsheet. So you can go through this model when I'll share with you. The parameters are there within. Okay, like suppose I can show you one of the parameter here. You can see just quickly here, like this blue shaded parameters. These are the ones which are linked with your spreadsheet. So now we will quickly see that with an exercise file. So let me just close this one. This was our spreadsheet. Let me just close this. Let me open the exercise file which I have prepared for you so that you can live see how you can take use of the beneficial spreadsheet workbench. So here we have a model. Let me just quickly make it the elements as transparent so that we can uh, navigate through our model very finely. And let me make it orthographic. So here we have a very small house like with two columns, internal walls and an opening. Okay, and the extended wall, parapet. Uh, Above we have the roof and the basic floor. So now we want to make this model parametric. Right now I have given the dimensions for just your convenience. So let's start with it then. So at top you see this workbench. Here you simply navigate to your spreadsheet workbench. All right, and then here are certain operations for workbench. The first thing here you can see is create a new spreadsheet. Fine, you can navigate through here or you can click on here and create new spreadsheet and then double click here. Okay, and while working simultaneously with your model and spreadsheet, it's better to make the Windows ads tile. So go to Windows and click on tile. Okay, so now simultaneously you have both the views, you have the model as well and you have your special workbench bench as well. Let me make it as no shading. Yeah, you can see the beautiful colors. Okay, so now starting with, you can do both ways. You can assign your parameters on the model or on spreadsheet, but the better practice is you start with assigning your desired parameters on a spreadsheet, make your overall wireframe, and then move to your model, and there you can define the or apply the constraints with respect to your spreadsheet. Okay, guys. So here you can give the heading column as parametric house. Okay, and I can merge this. Suppose I want to merge from here to here. So here you have an option called merge selected cells. Okay, ji. And then you can right click on this. You have certain properties like you can change the text, color text, the background color. You can make alignment. So these type of things you can obviously do anytime. Okay, the style, the bold. Okay, display unit. We don't need unit here. And allies. Allies, I'll just tell you how exactly beneficial it is for us. Click OK. So this tutorial gonna be long, so be stay patient and it's gonna be really beneficial for you. Okay, just stay along till the end of the video to gain maximum benefit. Now starting with, if you see the top plan, we are interested in the internal dimensions of our house. So you can see it's 10 feet by 12 feet. So let's enter here. Um, we can say it as room length, and next parameter can be room width. Fine. Length, you can say it as 10 feet on the y-axis. Width is 12 feet. I'm just writing tentative here. Right now these are not linked. Okay, we'll link it later on. Right now we're preparing a wireframe for our use. Then moving forward, we have this opening you see here, which is 4 feet. So you can write here opening width. This you can write as 4 feet. Right now just taking dimensions from there. Later on we'll link it. And you will see the live changes in the model as well and the dimensions as well. Fine. Then we have a distance here which I didn't mention here, which was uh, distance of the opening from the left side, or you can say opening offset. Okay, this is from left side. Then we have this wall extended one, which is this wall, this one, which is 5 feet extended. The length is 5 feet. So you can call it as wall extends. Fine. This can be 5 feet, and above we forgot to mention the opening offset can be like 2 feet for time being. Okay. Then we have these two columns which are of equal dimension, obviously, which you can assign it as. So meanwhile, we just skipped one thing, which was the wall thickness and the wall height. Okay, let's take it later on. Now we have oh, okay, let's write it now here only. You can say the wall thickness. Let's make it 5 inches. Okay, just take care of the dimension that we're putting, and later on we'll assign dimensions. Then you can say, you can write with the wall height, which is the internal wall, that's height. And then you can simply write the height of wall extends, or simply write extends height. Fine. Then let's come with the column dimensions, which is the column length, and then the column width. Okay. Okay, so we're done with the elements. Then we have wall height, you can mention as 10 feet. Wall extends, you can mention at 5 feet. Column length, right now, just pick it from here only quickly, which is 2 feet, and then the 1 feet as width. Okay, guys. Then you have certain other parameters, like you can say, yeah, this depth of the parapet. Okay, let's mention here parapet depth. Fine. Then you can mention this offset of the, um, you can say, the slab above. You can write as slab. First of all, slab thickness, obviously. Okay. And then you can just insert a row also here. Right click on it here and insert rows. And you can write here as parapet thickness. There are lots of parameters. So parapet depth, you can take it as 2 feet. Okay, thickness you can enter as 4 inches. Slab thickness, again 4 inches is fine. Okay, so these parameters are quite done. Now at the bottom you have the floor, and floor also be given some offsets with the adjoining geometry. So you can simply conclude by the floor offset, which you can write as 3 feet, and then you can give the finally the floor thickness as 4 inches is fine. Now we'll start linking, but before linking, thing that you need to take here is assembling your overall spreadsheet in terms of units and allies. Allies is basically, you can say, a second name, a secondary name given to your particular dimension, which becomes easy for you while linking with your constraints. If in case you are linking it by, suppose this comes under B column and a row is 2, like B2. But if in case you have inserted a row here, okay, this will become B3. So you have to revisit your particular constraint and make changes there. Okay, so we'll follow the rule of allies here, but before that, let's make certain units. So you can see from room length to wall extents, all of these dimensions are in feet. So we'll right click on the properties, we'll go to display unit and just write unit string as ft, which is feet. Okay, beautiful, done. Then you have wall thickness, make it as inches, or you can select all the things which are inches. This is in inches. Few things are inches, then the parapet thickness and your slab thickness, properties, and right here simply in. This has become in inches. Then from this to this, and your floor offset. Okay, this was also in inches. Okay, I'll do that. So this will be in your feet, and your floor thickness will again come in inches. So now this is for our own convenience that whether our things are in which unit, are this in feet or inches. So it becomes easy for us while making changes here. Okay, now we'll shift to our model where we will be assigning these parameters to the constraints of our geometry. Okay, so first thing is room length. So this is the wall, okay, the main wall sketch. Just open its sketch. Okay, so the room length was this one. So now what you need to do here is just double click. But before that, one thing you need to take here is just remember the name of your spreadsheet. You can rename it also, like you can rename it as my parametric house design data, my house data. But let's move with simple thing spreadsheet, okay? Because we will recording this name while recalling in the constraints. Fine. So go to the sketch. We are interested in this dimension and making it as the length of the room. Double click it, okay? And go to your formula. And here you can enter this particular constraint. But as you know, we haven't given the alias yet. Okay, so click on this particular parameter, go to alias. Okay, so you can enter any name which you want to be recalling in your particular sketches. So we can give this as room L, which is fine. Okay, and to your room width, you can give it as room capital W. And notice here one thing is when you give alias to your parameter, it becomes yellow in shading. The background becomes yellow. This is to signify and makes user identify easily which of the parameters are by a given username defined by the user. So you click on it and you can see the alias here, room L. So this is the parameter by which we'll be recalling in the constraint. Similarly, opening width also let's give it because all of these things are coming in the particular same sketch only, same geometry. The opening width you can give it as opening W. Try to make your alias as short as possible and make it uh, good and readable also. Like it should be easily readable to you and easily recognizable also for your future use. Then it comes the opening offset. Okay, this we can give as opening O. Okay. Okay, we're done with this thing. Now moving to your sketch, double click on this parameter, go to the FX, the small key here, and now you need to enter your constraint. So this is the thing here. So it will start with, firstly, the spreadsheet, the name, which is, so it will show you here. Okay, now just mention the alias name. Alias name, the first one was, and it will show you automatically, it was room L. Click enter, click OK, and you can see the value has come here. It becomes yellow because this is getting redirected from certain thing. That's why it's coming yellow in color. Now I'll move to your this dimension. Double click, click on FX, and we'll assign here. Just write spreadsheet and click here. It automatically fill the remaining space, and then you write here room W. All right. Click OK. Click OK here. This is also assigned. So now you understand the basic terminology. So we'll be moving bit fast here. This thing, which is offset. So this will become your spreadsheet. Make sure the spellings are same, but it will automatically get it here. Then your opening. Oh, okay. Click OK. Then finally your opening width, which was spreadsheet dot opening width. Clear? Click OK, click OK, and close the sketch. Now what I will do is let me hide this geometry to quickly show you in the top view. What we'll do is we'll change the dimensions from here. Suppose I change the room length to 14 feet with this symbol and click enter, and then you see it changes. I'll make it 15 feet say, and you can see it's changing dynamically. and dimension is also linked. So it's very beautiful to see overall. Room width, we can make it as 13 feet, and you see it changed. Then move with the opening width. This is what this was 4 feet. Let's make it 5 feet, and see opening has increased. Finally, the opening offset, you can make it as 4 feet, and you see opening has moved. So how interesting this thing becomes and how convenient for you while making changes. Okay, now let's move forward with our upcoming constraints. So now then we have the wall extents, the wall thickness. Okay, the wall thickness basically will be same. We have kept same for your internal room wall and extends wall. So what you can do is click on this wall and then click on this wall. You can also use your tree view here and very carefully go to data properties here, and then below at the bottom you have the wall width assigned as 5 inches. Click on it, but the thing here is you can assign formula one at a time for one geometry. Okay, so we'll move one by one and then we'll copy the constraint. So click on this wall, click on the width, and then you have the FX thing here. You got it now. Click here and write spreadsheet. Then it was for your wall thickness, but this alias we have to define yet. Okay, make sure you define it. So the wall extends alias, we can keep it as, you can right click, you can click here also, you can right click here and then enter alias here. But it's very convenient to simply click on your particular unit or the value and just enter alias here. So the wall extends alias can be uh, simply wall and ext like this. Easy to remember. Wall thickness you can give as wall T. Fine, capital T. Then the wall height you can give as wall capital H. Perfect. Then extend heights is basically smaller, or that's a kept as different value. So you can write this as EXTH. Okay. Column length and width. Okay, we'll move it forward. Let's finish the wall thing first. So click on this wall, the outer wall basically from here you can see, and go to the width parameter. Click on the formula. So we'll write it here as spreadsheet. Um, it was thickness, so we'll write it as wall T. Got it? Click OK. Now similarly, you're interested in the height. You can see height parameter. So click here. You can see this turned to blue because this is coming from spreadsheet. Click on the formula. Right here spreadsheet dot wall H, which was the wall height. Click OK, and now you click outside. Perfect. Then let's move with your extents. Here we want to keep the height from here, which was spreadsheet dot exth. The width of this wall we want to keep same as it is with that one, so we can write here spreadsheet dot wall thickness, which was this one. Click OK. Fine. We are done with the wall thing. Now moving forward, we can say the column length. Let's assign this as COL simply, and then capital L, enter. Column width you can give as COL and capital W. Okay, done with this. Then the parapet depth, you can give it as, parapet depth is this one, this green thing, the outer parapet, how deep it is. Let's assign all alias at once now only. So parapet depth you can give as PAR, parapet D, capital D, enter. And moving for parapet thickness, oh sorry, we'll click on alias, parapet, capital T. Okay, Then we come to the slab thickness. Slab thickness is this cream color. So you can write it as slab, capital T, enter. Then we have the floor offset, which is below 1. So this we can give as floor, capital O, enter. And then floor thickness. Make sure to press enter while assigning alias. Floor thickness can be floor, capital T. So we are done with assigning all our alias and this turned yellow. So we were with the column thing. Okay. Now we go to columns here. You can see they are in single sketch. So what we'll do is we'll open their sketches from here. Sketch here. You can see 1 feet by 2 feet, and this has been made equal to that. Okay. So this was the width thing. So we'll double click here. Okay. Go to your formula and we'll write here as spreadsheet dot col capital L, which was the length. Click OK. um, Sorry, this was the width, not a problem. Okay, click OK. Moving with the length, which is this one in y direction, go to formula spreadsheet dot col length. All right guys, click OK, here. Then we can close. All right. One thing more, our columns are basically in same height with respect to your wall. So what you can do here is click on the columns. They're not given the height here, which is not required because they're moving with the wall actually. So, but for our convenience, we have to mention the formula here as well for the columns height. So write spreadsheet. So the height will be same as wall. So wall H. Okay. So now they are in same height. Now we're done with the wall column length, column width. Now let's move with the parapet width, which will be quite beneficial to you. And this is mapped to your slab. So parapet depth, you can go to parapet wall here, which I model as wall element. Go to its sketch. But before going to sketch, the depth is basically in the wall parameter only. So you can see the height, okay, which is 2 feet. So you can simply assign the formula here as spreadsheet dot parapet d, which is the depth. And thickness, you can give again from the wall component here. Go below here, we have the width here. Go to formula spreadsheet dot parapet t, which was the thickness assigned. Click OK. Done guys. Then moving forward after this, we had the slab thickness, which is this one. So click on it. So here we have the height, the slab thickness basically. Click on the formula part, write spreadsheet dot slab t. Click enter, click OK. Perfectly done. Then comes your below floor. But before moving to floor, one thing you need to take care is when you will change the wall height, the floor won't move because the sketch is not constrained. Okay, as I'll quickly show you this slab and this sketch, which is this one. So it is somewhere in the space in the Z direction. So in the placement of this sketch, click on the sketch. So here you have the placement because the slab is basically constrained with the sketch. So this position, which is 10 feet, this we have to constrain with the wall height. So click on the formula. Okay, so there are certain things that you will need to take care to make overall things quite tight in terms of constraint to make it fully parametric. You will learn with the practice. So you can write it wall H, click OK, and you are done. Now we're moving to the last thing, which was the floor offset. Go to your floor component. So here you need to go to your sketch. So here you can see 3 feet, 3 feet. These are the offset defined for your floor. So we'll double click it here, go to formula, and we'll copy it to all the offsets here. We'll write spreadsheet dot floor O. And let me just quickly copy this. Click OK, OK. and will assign to all the offsets given here in all three directions. Okay, so we're done with the offset thing also. Final thing is the floor thickness, which lies in this object, and you move below. Here you have the height of this floor, which is the thickness obviously. So you sign the formula spreadsheet dot floor thickness. Click OK. So now you're done with assigning all of your constraints, and now the thing is to just make changes in your spreadsheet, and you can see the live changes in your model. So let's start. Room length was 15 feet by 13. So this we have seen already. Okay, let's do it for time being. 14 feet. Done. Room width is 13 feet. You can make it as 15 feet. Broadened. So here is a slightly offset, which is not moving with this particular wall. So you can see that that's a correction we can do. Go to your sketch. But this is 3 feet, which is already beautifully going on. But still the issue is coming. Okay, anyways, we'll see that. Now moving forward, we have the opening width, which is this one. 5 feet it was. We can make it quite smaller, which is 4 feet is okay. And the offset can be 3 feet from the left wall, and it is moved. Then we have the wall extend length, which was this one. These walls, these two walls. These we can make it as 6 feet, say. I think these we have not assigned. Yes, we forgot. Okay, no problem. So go to wall extends sketches here. This 5 feet, correct? So double click on it here. Go to formula, spreadsheet dot wall extend, wall ext simply. Click enter. Okay, okay, and you are done. You can see 6 feet. I'll make changes again, like 8 feet here. And you can see it's extended beautifully. Fine. Moving forward, the wall height, which is 10 feet right now, you can see we can make it as 12 feet. And you see your things are moved, but the parapet sketch has not moved. So for that also, what you need to do is basically the parapet sketch also need to be moved as per the height. So this is how you basically learns with practice, and you can see where your errors are. So here you go to placement of the sketch, position. So you see this is not constrained. So I add formula here, spreadsheet dot simply the wall height. Same parameter will be useful here as well. So you see it moved automatically. Fine. Then this slab is actually creating a problem for your overall thing here. So this slab is not getting rightly constrained, as you can see. It is constrained. So this was supposed to be at a certain offset, which you have given here, 2 feet by 2 feet. Okay guys, not a problem. I'll just quickly make a changes here. So let's make it straight. Okay. This distance we can also make as. However, this offset we have not given in our constraint lists, but it's okay. Let's keep it fixed for time being. Just 2 feet, 2 feet, 2 feet, and click close. Okay, so this is also fine for us. Now the column length, these two columns. So we can give it as suppose 3 feet. The length has been moved. The column width we can give as 2 feet. Okay, this has also been extended. Now the parapet thickness, which is this thickness, I have made it transparent for your easy convenience. So this you can make it as parapet thickness 4 inches is there, 6 inches. Obviously it's quite much, but you can see it has been changed. Now the slab thickness, the above one, this is 4 inches. You can make it as 1 feet, which is too much. Okay, but let's make it again uh, back as 6 inches is fine. Okay, the floor offset, the below 3 feet were there, you can make it as 5 feet, and you can see it has moved uniformly. The floor thickness you can make as 1 feet, just to show you changes here. You can see, but the 6 or 5 inches is enough. So guys, what we learned here, how to parametrically control your overall model beautifully using the easily convenient spreadsheet workbench, which is in your hand. So I'll share this model with you. Okay, you can make whatever changes you like to make here, and then you can also study this, how the things are going on, and it will be quite useful for you to make your models parametric. Usually you might have seen uh, things parametric work spreadsheet using for your part design basically, but never for your BIM workbench, for your BIM objects. So here you can see the spreadsheet workbench is not only essential for your part design tools or your part objects or your mechanical objects, but you can also use it for your architectural tools as well, for your architectural objects. So this was it guys, I think, in this tutorial. If you have any questions, let me know with your valuable comments in the section below, and we'll see how we can move forward with some exciting new tutorials which can be beneficial for your day-to-day practice. So that was it guys. Thank you so much. See you in the next tutorial. This was Nirbhay Chauhan. Take care. Goodbye.